Intro to the web. In this video, we will answer the question, what is the Internet and World Wide Web? How to browse and publish to the web while discovering terms to know, as well as the future of where the web is heading. Let's start with the Internet. To understand how the Internet works, we must first understand protocols. Simply put, a protocol allows for the exchange of information between electronic items such as laptops, desktops, and mobile phones, etc. In computing terms, a protocol or communication protocol is a set of rules in which computers communicate with each other. The protocol says what part of the conversation comes at what time. It also says how to end the communication. Internet protocol is responsible for addressing, sending, and receiving the data packets over the Internet. The red line in this illustration represents the protocol or connection between the two computers through the Internet. This is called an Internet protocol, or IP for short. This is a simplified diagram, of course, but it shows how the data will relay through multiple computers connected online before reaching its final destination. You may have heard of TCP/IP before. The TCP stands for Transmission Control Protocol, which is responsible for breaking down data into small packets before it can be sent over the network, and for reassembling the packets again when it arrives. There are a lot of additional protocols which we'll discuss later in this video series, but let's first define what the Internet is. In its simplest form, the Internet is made up of a bunch of computers all connected together sharing information. The Internet connects the world electronically, allowing for us to send email, share files, use Facebook, make calls through Skype, and other interactions. In this illustration, the cloud represents the Internet. Back in the day, a cloud drawing was used to represent a telephone network, later used to depict the Internet. The Internet does not live in the sky. Ironically enough, most of the cables that connect the Internet together are actually underground or even underwater. Nevertheless, it's a good metaphor for a series of connected computers, which we'll explore more shortly. So what is a web server, and how is it different from my home or work computer? Well, a server is a computer that acts as a relay or is used to store some files. These computers or servers make up the foundation of the Internet. While even our home computer or office computer could be configured to host files and even websites, if we turn off our computer at home or get disconnected from the Internet, the files that were on it are no longer accessible to other people on the Internet. So we use special computers built for speed that are always on and connected to the Internet to store our files. To better visualize the Internet, it's important to understand that there are actually a lot of computers which are connected together that all communicate. These servers connect to other servers, which connect to other servers, which are all connected to share more information. The Internet is designed so that even if a server gets turned off, there's some logic that can actually keep the Internet online. So the idea is that there's this decentralization, so we can't turn off the Internet, so to speak, without some sort of unrealistic worldwide effort to do so. To connect to the Internet, we either use a laptop that connects wirelessly to a router, or a desktop that connects through the router, through your Ethernet cable to the router. The router then connects to our modem, which connects to an internet service provider in order to get access to the Internet. It's kind of like our internet service provider is like a gateway to the Internet. So newer generations may take kind of Internet connections a little bit for granted because of the widespread communication connectivity that we have today. But a lot of us have taken a front row seat to the evolution over the years, from a dial-up, through your phone line to now what we have very fast, dedicated connections. So once you're on the Internet, you can access other computers which form the Internet and the World Wide Web. We've all seen or heard www. This is used in website addresses. It stands for World Wide Web and was invented in the early 1990s as a subset of the Internet. This could be thought of like a graphical interface to the Internet, and it gives us a way to identify or locate files or any online resource that's identified by what's called a Uniform Resource Locator, or a URL. These URLs, often referred to as links, can be navigated using hyperlinks, which we'll go into a little bit here shortly. So here's an illustration. On the outer ring, we have the Internet. Inside, we have the World Wide Web. Later in the series, we'll expand on this graph a little bit more, but notice that what we're actually starting with right now is what we call the surface web, or the part of the Internet that can be accessed through Internet search engines. So when we want to access the World Wide Web, we type in http:// www dot and then the domain name or full address that we want to go to. It's important to explain that for domains without a local network, like a lot of bigger corporations have, you don't actually need the www prefix in the URL, as most of the servers are configured to find that file you're looking for, the domain name you're looking for, even without using www. A lot of times, though, if you are in a larger network, to access your public website, you'll need to put that www to take you outside of your local network. So that's what it's there for. The same is true for adding files that you want to access on the domain, as the server is typically configured to have a default file. So you could actually just go to mydomain.com versus mydomain.com/index.html or index.php. So if you don't specify it, it just looks for the default file. So this request is sent through another protocol let's learn about, and that's called the Hypertext Transfer Protocol, or HTTP. And that's that part at the beginning of the address that we always see in our browser. This is a request that is sent that says, hey, I'd like to access this file. And in an oversimplified explanation of it, it just returns back the file we're looking for. When we want to send information that's sensitive, such as like a credit card number or social security numbers, we want to encrypt the transmission so that other people can't, maybe we're on a shared network or we're, Wi-Fi in a Starbucks, and we don't want people, kind of sniffing out those packets to find our sensitive information. So that's what we use the S in HTTPS, or the Secure Hypertext Transfer Protocol. In order to encrypt or secure this connection, we use an SSL certificate. And that certificate is really linked between the browser and the server that encrypts the communication. So SSL, or Secure Socket Layer. So let's recap. Internet's a bunch of connected computers which talk through protocols. We store files on the specialized computers we call servers, where others can access the information from other internet-connected devices. And we access these files through Hypertext Transfer Protocol, which we know is HTTP, the part we type in a web browser. So let's discuss how to find a computer or server. This is done using an Internet Protocol, or IP address. An IP address is used the same way that we have kind of physical locations have a street address for maybe our office or home. These are assigned so that we can find our way there easily. The same way that we have neighborhoods and addresses offline is true with online locations. So locations on the internet have numerical locations called an IP, or Internet Protocol address. We can access a web server by entering in that IP address. Now, note that most of the servers have more than one IP address. Or I should say most of the websites can share the same IP address. So in order to keep things simple for this illustration, though, we're going to assume that they're on a dedicated IP address, or that there's only one website on a given IP. Nobody would use an IP address to refer to their website because it's really inconvenient, right? It's hard to remember. You can't imagine a radio advertisement saying, visit us on the web at 128.1.0.1 or whatever the number. It would make it really hard for someone to remember that later on and find our site. So what we use is a friendly way to point to a website, and that's what we call a domain name. So we'll have maybe visit us on the web at company.com, or where the company.com is called a domain name. Pretty straightforward. Let's dive in further. So a domain name gives us an easy way to reference a website's location. In the example we used with company.com, the .com part of the example is actually the domain's extension. So there are a lot of different domain extensions. We've seen them ranging from .com, which is commercial, .org is organizational, .net is network, .gov for government, .edu for education, and so on. Additionally, each country has their own domain extension. In the United States, we use .us. The United Kingdom is .uk, and so on. There are a lot of different rules for who can purchase international extensions. Some countries require you to have a local address, actually like live there, to buy that domain name. And note that you actually never really own a domain name. You're really just renting it. There are a lot of other extensions, biz, .co, all these other extensions that we utilize as well that are becoming very common. But let's really just get back to the idea of that a domain name is equal to an IP address in its simplest form. So how does a domain name know what IP address to route to when you enter a domain name? Well, the answer is DNS, or Domain Name System. Think of DNS like like a telephone operator switchboard, or technically a database of domains and their corresponding IP addresses. So when you type in a domain name, it hits the name server, resolves to an IP address, and forwards your request onto them. So when your webmaster says, I need you to point your DNS to this A record, it may sound confusing, but that just means you need to update where your website kind of points to, right? So an A record is the record that corresponds to your website, and the MX record points to your or resolves for your email. So note that it's best practice, and I say this a lot, but really important, it's best practice to ensure your DNS stays hosted with where you purchase your domain name. If you allow your webmaster to move your DNS, you actually lose control. Really keep your DNS with your domain registrar. Otherwise, if you get a new webmaster down the road, you're going to need to move that back. And when you're moving DNS, it can actually take 24, even 48 hours for it to update across the entire world, across the entire internet. If you're just updating an A record, it can be instantaneous. So there's a lot of reasons I say this all the time. For all my clients, I ensure that I ensure they register their own domain name directly, and two, I ensure that they keep their DNS managed with their registrar. Okay, so the next section we're going to cover is browsing the web. In earlier slides, we referenced a web browser. Now, this is commonly referred to as a browser. It's a program on your computer or phone that lets you request information from the World Wide Web. There are a number of different browsers in the market. Companies really want this space, right? They want to have a browser because now they can really track what what sites you're visiting, and there's a lot of data collection happens from the browser level. This is why Google develops and maintains Google Chrome at no charge to the consumer. As of 2017, just earlier this year, according to the federal government's Digital Analytics Program, DAP, Chrome currently dominates the market with over 44% market share. This is kind of small, actually, compared to what Microsoft's Internet Explorer had. Back in the day, it was about 90%. So, their internet, Microsoft's really, their total market share is down to about, less than 20%. Internet Explorer is really the worst thing ever made. It was a nightmare to webmasters. It was a nightmare in general. So they re-released, they still have 15%. And that's because they were maintaining these, as they issued computers, they issued operating systems, Windows, etc. It just came with Internet Explorer kind of built in. Right now, they've got about 15% still with that horrible monstrosity of a browser. And they've launched a new thing because they realized how bad it was. They launched it from the ground up called Microsoft Edge. And they've gained about 3.5% market share. Firefox is about 7%. And Safari, which comes with your iOS, and as well as with your Mac OS, is about 25%. So when we look at that, Chrome is still the dominating piece. There are other browsers, out there, as well as we'll talk about later, Tor browsers, which kind of access the deep or dark part of the web. We'll get into that later. So understanding a browser's job is really just to request information, and then when it gets that information, turn it into something that we can see. So this again uses the HyperText transfer protocol to request a file and then display the file in the browser. So the browser requests a file from the server and then converts it into something we can see visually, as in this slide shows. When we look at a website, we don't often think about what's behind it though. If we were ever to view the source of a website, we would see that there's a markup language used to create the page. This markup is called Hypertext Markup Language, or HTML. There are a lot of other files that reference, or utilize HTML, including images, fonts, colors, interactions, etc. So the HTML file pulls in other files, which are kind of brought together by the browser to form what we see. As mentioned, HTML stands for Hypertext Markup Language, and this is considered the language of the web. So an HTML document is a plain text file that is read by the browser. An HTML document is made up of a few different sections. In newer versions of HTML, we start including a document type and then a series of other HTML tags that really give the browser instructions on how to display the document. So a tag is comprised of a left and right angle bracket with a greater, essentially the greater than or less than symbol that surrounds the tag inside the name of the tag. So most tags come in pairs and are used to surround other markup. An example is the HTML tag, which we see at the start of this and then again at the end of the document. You may have noticed that the tag that at the end that's kind of like the pair includes a backslash to indicate that the tag pair is closing. In instances where a tag does not have a closing pair, such as like an image or meta tag, you'll notice that there's a trailing slash is used at the end of the tag. So HTML tags wrap the header and body tags. The header tags wrap the instructions that are given kind of behind the scenes to the browser on how to form the website. That could be the title, it could be pulling in files, etc. As well as the body tag wraps around what we see in the browser window. There's a full video on how to do HTML. I've pulled it out of this course just to kind of really keep focused on what the internet is. But if you visit DIY-DIFM.com, there's a full free tutorial on how to learn HTML. So we've used the term hypertext a lot, and it's in the first two characters of HTML. It's also in the protocol. Hypertext transfer markup. But let's talk about hypertext transfer protocol, But let's also talk about what is a hyperlink. So in order for you to jump from one page to another on the web, you can either type in the address, or if you're already on a page, you can just click a link, and that hyperlink takes you to another page or another URL. In terms of links on the web, a link is a hyperlink and is essentially text that's anchored to the link that you can click on. Here's an illustration. So the action of clicking from clicking on a link or the blue underlined text, as it often is, that takes you to another page, is called the hyperlink. The text that we click on is called hypertext. So here's the HTML source or the code that creates a hyperlink. Here you can see we use the tag A, or the anchor tag, and then the attribute ahref, or hypertext reference, which shows where to link to. Here's another example where we add an attribute for a title, which we'll talk more about soon. So, publishing a website. In this portion, we're going to answer a few questions on how to publish to the web, as well as talk about different content management systems or modern ways to manage websites. How to publish a website? Well, typically, you'll start on your computer. You'll create, an HTML document. You'll include different images, and then what you'll do is you'll secure a web host. So maybe you'll get a host from any of the, GoDaddy or whoever you'd like, and you'll then purchase that web server, that web host, and then you'll upload your files from your computer up to the web server. Once they're on the web server, then other people can also see them. Now, the process of sending the files from your computer up to the web server uses FTP. And FTP, we'll talk about in a little bit, is File Transfer Protocol. So another protocol that allows you to communicate, send files up and back from the server. So once those files are on the server, anyone else can now browse, assuming they're public, can now browse to those files in the World Wide Web. Now, again, they'll connect those files using an IP address. So they'll look up, put in the IP address or the domain name. Okay, so let's talk about that FTP. FTP, simply put, is a protocol that allows the exchange of information between different electronic items. File Transfer Protocol, again, you'll use a different programs on your computer to send files or request files from web servers. To do this, most of the time, you're going to need to have authentication. You're going to need to log in order to exchange those files. To do this, you're going to need FTP software. So there's different FTP software on the market, such as FileZilla, etc. And this is programmed just like a browser. His job is to request and send information over the internet. The only difference is FTP is using File Transfer Protocol, whereas a browser is using HTTP. So let's talk about a content management system, because a lot of us would never actually publish files by putting them on our computer and then uploading to the internet. Most of us are going to actually create and edit our content directly on the internet. So a content management system, or CMS, is a web application that makes it easy to manage a website, editing all the content. When one of the major aspects of a content management system is that you have an editor, and we also call it a WYSIWYG, or what you see is what you get, a visual editor that allows you, rather than editing code, you can actually just type text and all the code will be created behind the scenes. In this example here, on the right hand side, we just typed in meow, put a picture of a cat, and on the left hand side we have we can actually see, if we go into the source mode, we can actually see what code was written for us. So I'd like to kind of just mention real quick what WordPress is. Most of us probably know what WordPress is. I'm not sure the exact number at this point. I think it's probably somewhere between 25 and 40% of the internet is actually utilizes WordPress as their content management system. WordPress is great. It has really the largest online community. It's online, it's open source, means it's free, and most hosting providers will give it to you directly. When we talk about hosts, the host that I recommend would be WP Engine, which specializes in hosting WordPress sites. So, real quick recap, a content management system makes it easier to edit a website, and WordPress is the best content management system. There is actually another video on DIYDIFM.com that goes through a full how to use WordPress, as well as how to optimize WordPress for the search engines. So go to DIYDIFM.com to learn more about that. So let's take a little bit deeper dive. We've been talking about the surface web, but there's other aspects, right? So we have the internet, then we have, and that contains all of the protocols and all of the globally routable addresses. Then we have a subset, which is the World Wide Web, and this is the part of the internet that's accessible through a browser. Then we have the surface web, and this is the part that is actually indexed or is known by search engines. And this makes up the majority of what the internet that we actually use is considered in the surface web. But there's more. So the deeper web, the deep web, is actually part of the World Wide Web that's not discoverable for various reasons by search engines. And this could be because the content's password protected, because the site is set up where the search engine's crawlers can't actually find the content, or it's otherwise encrypted. So again, when we're looking at this, the deep web is really the portion of the web accessible content that the browser, accessible through a browser, that's not indexed by Google or other search engines. And we're going to go in deeper into other aspects. So, this is also considered deep net, invisible web, etc. It's quite a lot of content, and it's there because maybe it was dynamic, maybe it wasn't linked to. There's a lot of different reasons why we can't typically browse that content. Now, there's another subset, which is the dark web. And this is part of the World Wide Web that really is only accessible if you use a special software to access it. So when we look at kind of how this looks, we have, again, the dark web is really kind of a subsegment of the deep web. Also kind of, it's also kind of lives over the dark net. So when we look at this, the dark net are services and sites that are, not in the dark web. The part that can be browsed from the web would be considered the dark web. So the dark web is the World Wide Web content that's not part of the surface web, which is indexed by standard search engines. This is about reports, 100 times bigger, 500 times bigger, different reports on how much bigger this area is than surface web. The browser that you would use to browse the dark web is the Onion router or a Tor browser. The dark side, well, when we think about the dark web, we immediately think of things like, really illegal things, right? Whether it's, pornography, whether it's, trafficking of different goods and drugs and things like this. But there's actually also a light side of the dark web. And what I mean by that is, there is an age of information suppression that is able to, and surveillance, where we're able to actually, participate in a different part of the internet where we're not monitored. So the idea is that when you log in with a Tor browser, you're going to start by actually connecting through a device that kind of a VPN that will essentially kind of mask who you are. And when you connect through this, you can actually browse freely without worrying about the NSA or worrying about, some sort of oppressive leader in your country monitoring and then penalizing you for maybe organizing, some sort of communication for rallies or things like that. So there is definitely a light side of this. And I think that, in the future, we're going to really dive further into the dark web and we'll find really good uses for that. Because we really do need, with the amount of surveillance that's happening right now, there's a lot of control that comes with that. Anyway, just one person's opinion. So let's talk maybe about the future of the web. We all remember kind of, Web 1.0. Well, maybe most of us remember this. This is old school. It was really just a portal for information, right? So Web 1.0 is this portal. It was, later become a little bit more transactional, but for the most part, it was very static. We would retrieve an article, download a book, learn information about a person, etc. It was kind of almost one-way communication. In Web 2 or Web 2.0, this is really kind of the second stage of development of the web that allowed for more interaction. So this is where there's user-generated content through social media, etc., that really started to grow the web that we know now. So now we have collaboration. Same entities, same objects exist, but now for that article, we can collaborate on it. That song, we can review it. Right? The book, we can discuss it. So there's a lot more value and traction has happened since Web 2.0. So, where we go from here is subject to, interpretation, right? There is no definitive, what is Web 3, etc. But really, the way a lot of people look at it is Web 3 was the context, right? So this is the third evolution of the web that brings semantic information or kind of additional information with these entities, right? So now we're actually able to understand the relationship of content, not just participate with it. So again, same entities, but now an article is written by a person who's reading a book that's inspired by maybe another article that's discussed in a song, that references a book or is loved by another person, right? So now we have a relationship starts forming, and now context is now being applied using schema and using other ways to add more context. This is a great, kind of example of the semantic web and the layers that are in this. And there's another video that I have that dives into this a little bit deeper. But let's just kind of jump right into Web 4, right? And for me, I would consider, and I think a lot of other people consider Web 4 really being the adaptation of Internet of Things, right? So, we're moving into this now, right? In my house, my lights are all controlled by, they're Hue lights. And so they're all controlled by my mobile device. My front door, has essentially, is web accessible. So I know if somebody opens or unlocks it, or I know if I left it open, things like this. There's definitely, this is going to go a little bit further, right? At some point, our dryer will tell us that the lint thing is clogged, or we can even communicate with our shoes, right? We already have wearables on our wrists. Refrigerators could tell us that we're out of different food types. This already exists. It's not completely mainstream yet, but this certainly is the evolution for Web 4. Now, Web 5, when I look to kind of Web 5, I would look to Tim Berners-Lee, right? Sir Tim Berners-Lee was the creator of the World Wide Web, or he's the one that invented HTML, and so I would look to him to kind of almost say where he sees things going. And in a speech he gave, he saw Web 5 as the emotional web, or this concept where there's going to be an emotional interaction between humans and computers. Right now, the movement, the web is emotionally neutral, which means it doesn't perceive the user's feel or emotions, but it's believed that this could potentially change. And this is really the concept of artificial intelligence. We already have some concepts like this. We have Siri, right? We have Alexa. We have these different things where we can already start interacting with them, and artificial intelligence will just continue to improve. For more on this video series, head over to DIYDIFM.com and get the rest of these videos.